Hello, these notes go over the empirical formula. So first of all, just remember if at any point during the video it's going too fast, just make sure you pause it. You can write down what you need and then you can move on. So we have two things that are very similar, the molecular formula and the empirical formula. We are just focused on the empirical formula today. So it says it shows the atoms in the smallest whole number ratio that that formula can be written in. And you'll see once we go over the molecular formula how those two things are related. But go ahead and write both of those down, and then we'll talk about the molecular formula tomorrow. You can see from these list of steps, these are the things that we're going to do. So number one, if given the percent composition for a compound, assume you have a 100 grams sample and change all the percent signs to grams. So that is what we're going to do in our first example. So we have our 80% carbon. So it says that instead of 80%, we're going to think of it as grams. And when we get our 20%, instead of thinking of it as percent, we're going to think of it as grams. Right? We have hydrogen and we have carbon. So we're going to take our carbon and our hydrogen, and we're going to do what it tells us to do in step 2. Right? It tells us to convert the grams of each substance to moles. Well, we've done that kind of a million times by now, so that's pretty simple. We want to get to moles, so we have the units of grams. That goes on the bottom. And we know from looking at the periodic table, for carbon, it is 12.011, so rounded to one decimal place is 12.0. And we want to get to 1 mole. So what is 80 divided by 12? It comes out to be 6.66666. Now, we know we want to go to 3 sig figs, but I'm not going to round to 3 sig figs here because I'm going to have to do another step in my problem. So I'm going to go 6.66, there's my sig figs. I'm going to go 2 sig figs further and stop there. Okay, hydrogen. So for every 1.0 gram of hydrogen, you get 1 mole. So we are looking at 20.0 moles. So we've done step 2. Step 3, divide each of your mole values by the smallest mole value. Well, 6.6667 is our smallest mole value. So we're dividing both of those compounds, or both those elements, by that number. So 6.6667 divided by 6.6667 is obviously 1. But 20 divided by that number comes out to be 3. And what that tells you is that for carbon, your formula, it has 1 of them. And for hydrogen in your formula, you have 3 of them. So I'm just going to list them in the same order that they're listed in the problem. They listed carbon first, then they listed hydrogen. And I know that I have 1 carbon, and so I don't need to put a little 1 subscript there, but for the hydrogen, I need 3. And that's it, CH3. It's pretty much that easy. So let's look at sample 2 and 3. Sample 2 and 3, they already give us the information in grams, so we don't have to take our percent and convert them to grams, but we're just going to go with what we've got here. So we have 13.5 grams of calcium, right? We've got 10.8 grams of oxygen and 0.675 grams of hydrogen. So we're going to do our mole conversion for each one. Right, we have 1.0 grams in 1 mole for hydrogen. For oxygen, we have 16.0 grams, right, in every 1 mole, right, because on the periodic table it's 15.99999. And for calcium, well, calcium is 40.07, so that's 40.1. So we have 40.1 grams for every 1 mole. And we are going to divide all those out. So 13.5 divided by 40.1 gets us a really long decimal number. Again, our sig figs are 3, so I'm going to carry that to 5. So 0.33666 moles. 18.8 divided by 16 is 1.175 moles, and 0.675 divided by 1 is 0.675 moles. Now remember, our next step is divide by the smallest mole value. So divide by 0.33666, right? And we're going to divide each one by that value. And this number that it's going to give us is telling us how many of those elements are in the formula. So this formula only has one calcium in it. 1.175 divided by 0.33666 gets us 3.49. Ooh, that's ugly, right? 3.49. What the heck are we going to do with that? And then we get 0.675 divided by 0.33666, and that gets us 2. Well, we can't have 3.49 oxygens, right? And it was really 3.4902. Well, what we're going to do, because everything has to be in a whole number ratio, if you look back at that definition, we're just going to multiply everything by 2. So that means we have 2 calciums, and instead of 3.49, right, we have 7 oxygens, and instead of 2, we have 4 hydrogens. So our formula, right, calcium was listed first, and according to this, there are 2 of them. And then our next element was oxygen, written in the sentence, and it says that we have 7 of them. And our last element was hydrogen, and it says that we have 4 of them. So that is our empirical formula. Last one, if you need it, 29.08 grams of sodium, 40.56 grams of sulfur, 30.36 grams of oxygen, and we are doing that same process. Right, step 1, convert everything into moles. So what do we have for sodium? It's 22.99, so that rounds to 23.0. Right, for our sulfur, it is 32.06, so that rounds to 32.1. Our oxygen is 15.999, so that rounds to 16.0. We're going to divide all those values there. So 29.08 divided by 23 gives us, and we're 4, 4, and 4 sig figs here. So I'm going to go 1.264, and then I'm going to keep going, just to be careful, 3, 5. Right, I went out 2 past what I needed. And then I've got 40.56 divided by 32.1, 1.26355. Now going past 2 past on this isn't that big of a deal because we're going to end up dividing them by themselves, but it's good practice to get into. 30.36 divided by 16 gives us 1.8975. So when we divide by the smallest one, which basically these two are equal, 1.26355, 1.26355, right? Those are both obviously going to come out to be 1, basically. And divide this by 1.26355. That is going to give us 1.5017. Well, again, they have to be in whole number ratios. So what are we going to do? Because everything isn't in a whole number ratio, nice and clean like it was a number 1, right, where it just came out to be 1 and 3, we we've got to get them those whole number ratios. So if we multiply everything by 2, then we get 2, 2, and our 1.5 becomes 3, and now we can write our formula, right? Sodium comes first, and we know there's 2 of them. Sulfur comes second in the problem, and there's 2 of them. And our oxygen is listed last in the problem, and there are 3 of them. And that is your empirical formula notes. Hope that makes sense.